When chemists talk about matter, we really just mean stuff. We mean stuff that has mass and takes up space. And that's pretty general, so it can be helpful to break that down into some smaller categories. And one of those categories is pure substances. You'll want to watch the video on chemical and physical properties before this one. So, when we talk about pure substances, we're also talking about atoms versus molecules. An atom is the simplest form of an element that still has all the properties of the element, while a molecule is two or more atoms that are chemically connected together. So you can think about an atom as just being a ball all by itself, whereas a molecule is going to be multiple balls connected to one another. And they're connected in such a way that they act as a unit. You actually probably have already had practical experience with one of these, which looks kind of like Mickey Mouse, but which is water. It has one oxygen and two H's bonded together, and we call this a molecule because it's got two or more atoms bonded together. This molecule, you know, water, acts as a unit. It doesn't act like oxygen, and it doesn't act like hydrogen all by itself, which is good because oxygen's explosive and so is hydrogen. They're both highly combustible. So if you were going to boil water for your coffee, you might blow up your house if it didn't act as a unit and have completely different properties than the individual atoms that it started with. Water is also what's called a heteroatomic molecule because it has two different types of atoms in it. It's also referred to as triatomic because it contains three atoms. You might also have a diatomic molecule, which would have two atoms, or a polyatomic polyatomic molecule, which would have two or more atoms. If I had a molecule like this one up here, I could describe it as triatomic. In this case, though, all the atoms are the same type. Maybe these are all O's. Maybe this is O3. In which case, then, it wouldn't be heteroatomic because I have all the same types of atoms, and so this would be called a homoatomic molecule, because you'll have all the same type of atom present. Okay. Those pure substances that we're going to talk about are different than mixtures. So our first broad classification of matter is to split things into either a pure substance or a mixture. We're going to talk more about mixtures in a different video, but I'm just going to talk briefly about them here so you can see how they're different than pure substances. So pure substances, just like the name sounds, you've only got one thing, versus in a mixture, you have two or more substances present. A pure substance only has one set of properties, while a mixture has two or more sets of properties. And by properties, what we're referring to here is things like boiling points, or freezing points, or chemical changes that they do with, chemical reactions that they do with other substances. So in a pure substance, like for instance water, we know that water has one melting point and one boiling point. That's a pure substance. On the other hand, if you take some salt and you dissolve it in the water, the salt doesn't magically get the same boiling point as water. If you boil water that has salt in it, what happens to the water? Well, it boils all off, and where's the salt? Still there, because salt has kept its own individual properties. Pure substances are either going to be elements or compounds, while mixtures will either be homogeneous, meaning you have one visible phase, or heterogeneous, meaning you have two or more visible phases. So, let's talk about those elements. There's only one type of atom present. It could be a molecule or an atom. So I could have an atom all by itself, in which case we'd say, yes, that's an element. Or I could have a molecule of the same type of element, in which case that would also be an element. So both of these, this is an atomic element, it's present as an atom, and this one is present as a diatomic molecule. So we'd call it a diatomic molecule. It's an element present. Both of them are elements because in both cases I only have one type of atom present. That's a pretty important characteristic. Pure substances in general, we know, have one boiling point, one freezing point, etc. Compounds will have that as well. So the distinguishing feature that we'll find of elements is there's this only one type of atom. I mentioned compounds. They're the other type of pure substances. And this is what water is. It has two or more types of atom present. When we look at H2O, which you may have heard before, this 2 is telling me I have two H's. There's no 1 written here, but it's telling me I have one O in my molecule. And I can see this is H, this is O. Those are different types of elements. So I'm no longer talking about an element because I don't just have one type of atom present. Now I have two. So this makes this a compound. They are chemically bound together and they act as a unit, like we discussed earlier. They can only be present as a molecule. So you cannot have an atom of a compound. It doesn't work, because in order to have a compound, you have to have two or more types of atoms chemically bonded together. Again, just like an element, there's one set of chemical and physical properties. So let's look at some examples to sort of take your knowledge out here for a ride. And you might want to take a moment and read the question and then stop the video, think about what you think your answer is, maybe go back and look at what we've already talked about, and then run me talking about the answer to sort of test yourself. So we want to classify the following as elements, compounds, or neither. So our first question will be a substance which melts at 500 degrees Celsius. Our second question will be a substance which decomposes when heated. Our third will be heating the substance causes no change in it. And our fourth will be the substance cannot be broken down into simpler substances by chemical means. Oh, and I had one more. Our final one will be the substance cannot be broken down into simpler substances by physical means. So take a moment, stop the video, and decide whether you think each of these refers to either an element, a compound, or neither. And as in, you don't have enough information to decide whether it's an element or a compound or something else. Okay, so let's tackle this first one. A substance which melts at 500 degrees Celsius. Well, that has a single melting point, which is great. That tells us it's a pure substance, but it doesn't tell us enough information to help us distinguish between whether it's an element or a compound. So our answer to the first one is neither. We can't tell. We don't have enough information. In the second question, we have a substance which decomposes when heated. Well, if I have an element, then I simply have one type of atom, either present as an atom or present as a molecule. And when I heat it, I still have that same single type of atom. So decomposing is telling me there is a chemical change taking place, which means I have to have reorganized my substance. And in fact, I need to have broken it up into parts. So it makes more sense to think of something like water, or something, we'll just make up a random molecule here, that when I decompose it, it breaks the chemical bonds, and now I have two new substances, right? Here, I start with a compound, and when I decompose it, now I have two different types of elements. So decomposition is referring to the fact I'm breaking a compound down into simpler substances. So we know that an element can't do this, but a compound can. So this is definitely a compound. Heating the substance causes no change in it. This is an element, because if the substance was going to be changed by heat, then it would decompose and we'd have a compound. So this is an element. The substance cannot be broken down into simpler substances by chemical means. This chemical means is telling us we can't decompose it. We can't break it apart. Well, we know from our discussion up here that we can break compounds apart. So this describes an element. The last question says the substance cannot be broken down into simpler substances by physical means. Well, physical means, it's a lot of means. We're talking about things like boiling point and freezing point and melting points. Well, compounds can't be broken down by physical means. So I can't break water apart into simpler substances by melting it. All I do is take an ice cube, for instance, and when I melt it, I have liquid water. So I had an ice cube originally, which was water in the solid state. I melt it, I still have water. Nothing else happened. I just changed physical state. So physical means is just telling me I'm changing physical state. Elements and compounds, nothing's going to happen to them there. So neither of them can be broken down into simpler substances by physical means, which means that this description could apply to either a compound or an element, so I can't classify it. So actually I should say either rather than neither, but I only gave you this option, so we'll say either. Neither, excuse me. Really we mean either. Okay. More examples. Classify each of the pure substances below, A through G, as elements, compounds, or neither, or really unclassifiable. So in the first case, I have A reacting with B, and the reason I know they're reacting is this guy right here. This is a chemical reaction arrow. So it tells me a chemical reaction is occurring, and I'm making something different. I'm making C. Well, what I notice here is I can think about A as being a chunk of something and B as being a chunk of something, and I'm combining them together to make a bigger chunk. A, B, and this is C. And you'll notice here that I must have made some chemical bonds because A and B are no longer separate. So that means C must contain more than one type of element. So C has to be a compound. The question then is whether A and B must be elements or compounds, or we don't have enough information. So if I took, let's say A was an element, and I had A, and then let's use a real example here. So let's say I had sodium reacting with chlorine to make sodium chloride. So I have an element plus an element to make a compound. Okay, so A and B could be elements. The other thing that could be happening, though, is I could have some compound reacting with another compound to make an even bigger compound, super big compound. That could happen, too. So I don't have enough information to decide what A and B are. So we're going to say A and B rather than neither. We'll say unclassified. So A and B, we don't know. We don't have enough information. Okay, let's look at the next one. In this case, I'm starting with some substance and undergoes a chemical reaction, and then I make these guys over here. Think about it for a moment. Decide what you think about what D might be and what E, F, and G might be. Okay. So D is clearly being broken up into parts. And because that's the case, we know that D cannot be an element, because an element would only break up into one thing, right? You can't really break it up. So D has to be a compound. Now, I could be taking that compound and breaking it up into its individual elements, or I could be taking that compound and breaking it up into smaller chunks of compound. So E, F, and G are like A and B and above. We don't have enough info to decide whether it's an element or a compound.